Welcome to the lesson on symbols used in blueprints. Upon completion of this lesson, learners will be able to identify and differentiate between the various types of lines and symbols used in blueprints and recognize the overall characteristics of a part through geometric tolerances. A blueprint contains a large amount of data in a drawing sheet and therefore needs to use a lot of symbols and notations. These symbols, apart from the basic lines, help us to reduce the difficulty of drawing the microscopic details of each and every feature of a part. If a part requires the use of screws, it is important to designate this on the blueprint. This can be done through screw thread representation. There are three ways to represent a thread on a blueprint: detailed representation, schematic representation, and simplified representation. A detailed representation consists of the real view of the screw thread with details of shape, size, distance between each groove, and so on. The problem with the detailed representation is the amount of time it takes to complete the drawings and the difficulty in drawing such details. A schematic representation simplifies the thread details and is shown as parallel lines. The simplified representation portrays the information of the design with as little detail as possible, without losing its clarity and requirements. The finishing symbols are used in technical drawings to represent the type of texture and smoothness that is required by the product. If the materials are required to be removed from the product, it has to be done by milling, filing, turning, grinding, and other metal smoothing methods. A surface finish symbol is used to indicate the type of surface finish required along with the degree of smoothness that it has to achieve. The basic symbols for finishing are shown here on the left. The number 32 in each symbol indicates the amount of roughness that is required for the surface. The type of metal removal process that should be implemented for the production process may be mentioned on top of the horizontal bar of the symbol. Machine slots are designed to secure two parts together. There are two types of slots, the dovetail and the T-slots. The dovetail is shaped like a trapezoid, and the two parts fit together tightly, as shown in the picture. The T-slot is in the shape of T and slides into place to secure two parts together. The T-slots are also similar to the dovetail, but are stronger. A blueprint also contains abbreviations and symbols in order to convey certain instructions to the craftsmen or production technicians. Abbreviations take up less space than the word or phrase that they represent, so they're used commonly in blueprints. These abbreviations and symbols are universally accepted. Production technicians should be able to identify and differentiate these symbols and abbreviations. Some of the commonly used abbreviations are listed here, along with their descriptions. Geometric Dimensioning and Tolerances, also known as GD&T, is the international technical language used in blueprint drawings to describe the size, form, orientation, and location of features of a part. There are 5 types of geometric tolerances that describe various characteristics: form, profile, orientation, location, and runout. Form tolerances, as the name suggests, describe the form of the part and feature, such as its straightness, flatness, or roundness. Profile tolerances describe the boundaries of a surface. They can be very complex as they can define a variety of boundaries. Orientation tolerances describe the direction or alignment of a part or feature, such as if a feature is parallel or perpendicular to another feature. Location tolerances describe the location and placement of a feature or part, such as its position and relative symmetry. Lastly, the runout tolerances can describe straightness, profile, angularity, and other geometric characteristic variations of a feature or part. The table on this slide shows the geometric characteristics and their respective blueprint symbol. This table shows the most common of symbols used in blueprints and the associated terms. These symbols are standardized and used internationally to illustrate the characteristics of a part through its blueprint. Learners may pause the video to observe the symbols in detail. The feature control frame describes the feature that is marked in its geometric characteristic symbol, tolerance value, modifiers, and datum references. The figure on this slide shows an example of a feature control frame. The first box holds the geometric characteristic symbol. The second one holds the geometric tolerance symbols along with their modifying symbols and the value of the tolerances. The third one refers to the datum reference of the plane. If there is more than one datum as a reference, the number of compartments is increased to accommodate these datum lines. The control frame you see here indicates that the tolerance factor is the position with a cylindrical tolerance of 0.003 of maximum material between the datums marked B and C in the blueprint. Material condition modifiers are found in feature control boxes and are used to refer to a feature in its largest or smallest condition. Maximum material condition, abbreviated as MMC, is the condition of a feature size that contains the maximum amount of material based on the tolerance limits of size. Differing from MMC, the least material condition, abbreviated as LMC, is the condition of a feature size that contains the least amount of material based on the tolerance limits. The next two slides include an example to better explain this concept. Maximum and least material conditions are concepts that can be very confusing. So, let's review an example. The image on this slide shows a top view of a block with a hole feature within it. The hole diameter is 1 inch with a tolerance of plus or minus 0.005 inch. The maximum material condition is the maximum amount of material based on the tolerance limits of size. Think of the material as the part material in terms of weight. Therefore, the most amount of material that the part, not the feature, can have will occur when the feature is the smallest. The next condition is the least material condition. Consider the same image as in the previous slide. LMC is the least amount of material based on the tolerance limits of size. Again, think of the material as the part material in terms of weight. Therefore, the least amount of material that the part, not the feature, can have will occur when the feature is the largest. In summary, blueprints can contain various types of lines and symbols. Being able to identify and differentiate between these symbols will provide an effective interpretation of blueprints. Also, blueprints help determine the required geometric characteristics a product must have to meet quality standards. It is important to be able to read and interpret blueprints if you work in an industrial company. Thank you.